In this episode, we'll build a traffic light system for an ice highway section. Essentially how it's going to work is we'll drive around in our boat. These barriers come up as if it was a red light, and when it's come down, we're treating it as if it's a green light. And essentially we'll have the pressure plates, so you know that there's a boat there waiting for the lights to change. If you sit here, and then lights change, we can go through. Similarly to last episode, we'll be doing this with a finite state machine. Unlike last episode, however, this one will change based off the inputs rather than based mainly off what the current state is. So this is what's known as a state transition diagram, which can be best used to visualize this. As you can see, each state is listed and numbered. The arrows then represent the state transition based on the inputs. For example, if the system is in north green state, and there is a signal produced by someone waiting on the east road, the system will transition to the east road, or east green state rather, following the arrow. If there are no inputs, the state does not change, and this is indicated by the arrows labeled no input. Because it's possible that there are multiple inputs at any point in time, there needs to be a priority order for the next state to be transitioned to. This is done when generating the next state truth table for the finite state machines. This is the truth table for our next state logic. We have 4 input signals: N for north, E for east, SO for south, and W for west, corresponding to each of the 4 roads. There are also S1 and S2, which represent our current state, and SN1 and SN2, which represent our next state. As you may be able to read, the order of priority when transitioning between states goes from north, then east, then south, then west. This means if the system is in the north green state and there is an input from both the east and the west road, the system will transition to the east green state first. This results in the logic equations you can see on the right side of the table. This is what the next state logic looks like once it's been constructed, and once again we're taking the outputs of the registers and then bringing them around back to the logic gates, which we have on either side here. So this is S1 and this is S2. However, this time we also have to bring in the inputs from the roads. So if there's a boat parked on the road, we have these inputs here, which also go back to our logic gates. And the outputs of these logic gates are then fed back into the register here, like we did before. We also have a clock here that updates every few ticks. So if you want to build it, you just have to put 4 items in there. And this ensures the register doesn't update until all of the logic gates have finished calculating the correct next state, essentially. So we can enter in our desired states here. So 0 for the moment because that's north. We can request east and that will update. We have south and west. Once this is done, we can then move on to the output logic. And as you can see here, the output logic is relatively simple for this finite state machine. This is because the pistons are either up for a red light or down for a green light. And this results in the truth table and logic equations you can see here. And this is what it looks like once it's completed. So as you can see, we've just taken the output of our registers here, run it through our logic gates for each of the 4, traffic light barrier things. And we've also taken from our pressure plate the signal to request the lights change effectively. So what we have to do now is hop on our boat, forget how slidey boats are, and then voila. Around here. Lights will change every time. I hope you're not motion sick. Yeah, thank you for watching. Have a look at the channel for more, and good luck building this for yourselves. Bye for now.